This is where we left off the other night. Supposed to graph these. We were talking a little bit, the general topic was transitions. In other words, or transformations rather, shifts to the left, right, up, down, ultimately flips, turns, things like that. Now, in this case, all we got in terms of covering this the other night was we talked about, this is the fundamental one. You've got that the graph of this one in one of your handout sheets that I gave you. And it in turn has its origin at 0, which actually that is a multiplicity 2. That means that's going to be a touch and go, and this thing goes up like this and up like that. Okay. By the way, the 0.11 and -1,1 are parts of it. This one, in this case, the y-intercept is 1. Here's the graph. Here's the y-intercept. And this thing now goes up like this. So if you have a number added on to the end of one of these, all it does is move it up or down depending on what the sign is. Okay. Then we talked about this one. This one is just going to simply move it down 2 places. The y-intercept moves down. So this one goes like so. Now we can graph these without actually plotting them. This is what I call a sketch. Okay. The alternative to the sketch is to plot these. Now, here's the same 3 equations. If you look at this, and I'm going to leave these on here for a moment. They just arbitrarily chose these x values because x is what we call the independent variable. It can be whatever it wants to based on the domain rules for that problem. And then the y answers are a result of whatever these are in the equation. So in this case, if x is -3, x squared is +9. Well, so is +3 and +9. That's because that's why it has its symmetry. Okay. And then here we have -2, 4, -1, 1. I told you about them earlier. The 0.00 happens to be the vertex in this particular case. Okay. So that's the graph of this one. If you look at this, same set of x values. Only this time, if you have -3 for x, you end up, I do need to remove that. If x is -3, this gives me 9 plus 1 more makes 10. Okay, so that shifts that point up 1. And here, it's going to shift it up 1 and all the way across, and that's the way it works. Now, you could always graph this thing, and as you see, these are all 2 below what those were. Okay, compare, 2 below, and so on. So that's how vertical translations work. Can't use my pointer because it doesn't show up in the video. That red one, that's when I use that bigger green one most of the time, except it's at home on the charger. Okay, here's basically the same chart we just had up there, bigger. And here are the 3 graphs overlaid on one piece of graph paper. The black one was the original one, y = x squared. Okay, Notice the gap is 2 for every line. So right there is the 0.11, and right there is the -1,1. And this thing goes on up. Well, here it started out 1 higher and went up. Here started out 2 lower and went up. That's just more of what we already did. Generally speaking, what they want you to do is, assuming that this is a graph based on that, what would be the value of k in this equation? Well, we're down 8, so k would be -8. That's all this one is. Okay. And this just says what I have already said. That whatever this k is will give you a shift up or down compared to just that one. Now, it's because of this that that sheet that I gave you in your packet of basic graph functions, like y equal x squared, y equal x, y equal x cubed, y equals square root of x, all of those. That's why it's important that you learn those basic graph shapes, because a lot of time from graphing stuff, instead of having to do a chart, then you can just shift it left, right, up and down and that kind of stuff. Okay, so that's the goal. And by the way, when you get in 111, you're going to absolutely have to do that. All right, now in this is just more of what we've been talking about. If k is a positive 2, then the graph is shifted up 2 units. If k is -3, it's shifted down 3. And if in this case k is -4, so we've gone from here down 4, just more of the same. 7/2 is 3.5, so it goes up 3.5. Now, what about this? We're bringing in something a little different. I have introduced this to you before. This is not the first time you've seen this. The difference in this one and the difference in this one is this k is external to that x squared. In this one, this h is contained with the x. Now, when a number is contained with the x, then instead of shifting up and down, it's going to shift left and right, opposite of whatever the sign is here, the opposite direction. Okay, so that's the impact of this particular one. Set of equations. We've seen this one before, right? What's this one going to be? It's just going to be shifted one place to the left and go up here and here. If this one is this, okay, then this one is going to be shifted one to the left. Okay.
So even if it's positive, it's going to the left?
Opposite of sign is the rule. Okay. This one, 2 to the right. And that's what the difference is going to be. Now they're probably going to show me an XY set of charts to prove that again. Okay. So anyway, there are your values. And there are their 3 overlaid graphs. Theirs are prettier than mine. So you see here was the fundamental x squared one. This is x minus 1, or x plus 1 rather. And this one's x minus 2. Yes.
Do you want us to label which parabola is which, like they do on the test?
Absolutely. Absolutely. Except usually you're only going to have one on a problem. I might have you draw the original white x square one and then one other. Okay, what about this one? That one's going to go 7 places to the right. What about this one? Roughly, you know, this is 2, so there's 1. So that's about 1 and a little more than 1.5 over. Okay. What is a number in front of the variable going to do? Let's review. Let's review. You remember that from linear equations? Slope is 1 over 1, up 1 over 1, up 1 over 1, up 1 over, down 1 over 1, down 1 over. Okay. What if we had three x? Now, because there's no b out here, no number, that means the y-intercept is still at 0. Okay. But what's going to happen here? The slope is now 3 over 1, isn't it? So instead of going up 1 over 1, I go up 3 over 1, up 3 over 1, up 3 over 1, and now I'm at this angle, which is a much steeper angle. You see that? Guess what's going to happen on here?
It's going to make it either more narrow or wider.
It's going to either make it steeper or it's going to make it wider. If I had y equals 1/2 x, then in that case, the graph is going to look more like this, up 1 over 2. Okay? And the same will be here. If I have a 1/2 here, it's going to curve out wider like that. If I have a 3 here, instead of going at this angle, it's going to go at a steeper angle. So it's going to behave just like lines do in that respect. Okay, so let's look at their examples now. But I thought it might be useful to you to look at that background before we just jump into this. Because the language they're kind of particular about the language. So I wanted you to understand the concept before I started throwing their language in. Okay, here's my 3 equations. There's an XY table for them. Okay. What do these hieroglyphics up here at the top mean? This just means that this number right here is a positive number or 0. That means that it's a fraction. This notation means fraction because it's littler than 1 and bigger than 0. What's in there? Fractions or decimals. Okay. Well, anyway, we got this. And what's going to happen then if you look here, in this one, all of the y values are twice as high as they were before on the basic. In this one, all the y values are half as high as the original. Okay. So what do your graphs look like? In this case, black is the original again. 0 and 1, 1. Okay. Well, for the 2x, then it went up to 1, 2, and so on. So you see it's at a steeper angle here all along. For the half x, it only goes out here to 1, 1/2 and continues up. Okay, now this blue is called vertical stretching. Vertical stretching. Okay. This pink can be called horizontal. Uh-oh. Well, no, not stretching because it isn't steeper. Well, it does stretch horizontally, but what you've got here, I prefer the word steeper or flatter, but they've got their own language that we've got to deal with. Now, we'll pick that up in a moment. Here's another example with just simply a different set of fractions. Now, this one has got something new in it. A negative in front of it. When you put a negative in front of that, what that's going to do is it's going to reflect it left to right. When you change x to negative x, you switch sides of the graph paper. You switch sides of the y-axis. Does that make sense to you? Okay. If I change x to negative x, then I get a point, which is over here. It reflects it across the y-axis. Okay. If I had another point here, let's call this one 5, 1. If I change x to negative x, if I just arbitrarily do that, okay, then I would have this point, negative 5, 1. This point is reflected across that vertical, that y-axis. Okay? That is a hard and fast rule. If you replace x with negative x, it will reflect it across the y-axis. Well, what you suppose would happen if you replaced y with negative y? Then it would reflect across the x-axis, okay? And we'll get there in a few minutes. So now we've talked about slides and we've talked about reflections, okay? And what will trigger them? You see, all of these graphs are upside down simply because of those negatives. Okay. So if the first term of a parabola is negative, then this thing is going to be making an arch instead of a cup. Okay. Now, one silly way to remember that, and I can't do that because there's some water in this cup. If the first term is positive, this cup will hold water. But if the first term is negative, and like I said, I'm not going to do it because I don't want to have to clean up the mess of water on the floor, then this thing would be inverted. Okay. What is that symbol right there mean? That means that the A term, the first term, is a positive number, is all that means. Okay. Again, here, this is just talking about that. Vertical stretch, we talked about that. What is a vertical stretch? If this is a positive number bigger than 1, it stretches it, it makes it steeper. Okay. Now, this is the notation for fraction again. Okay. Now, what this is saying then, and the reason they got these absolute values is they don't want to let the A be negative to cause it to flip or flip this way. They're wanting to just play the fact that it's a fraction and not let the positive or negative impact. Is why they put that there. So what this is saying, if A is a fraction between 0 and 1, then it will be a vertical shrink or a horizontal stretch. Here's the basic. Okay. If this is a fraction, it'll look like this. In other words, out wider. Okay. Flatter, whatever you want to call it. But there are 2 words you can use with this. You can say it is vertically shrunk because it's not moving out as steeply as that one is. It takes it longer to get tall. Okay. And at the same time, it's kind of spreading out like I did when I was about 65. Okay. That didn't happen until after I retired. Anyway. Now, what does this one mean? Again, we're saying we just want positive numbers. If it's bigger than 1, meaning it's 2, 3, 1.5, 7 halves, whatever, anything bigger than 1, then what is it going to do? It's going to cause a vertical stretch because it's going to get taller faster. Okay. It's like when you were in the 7th grade and your great aunt came to visit you, hadn't seen you in a while. So, well, you stretched out, or something like that. Okay. Well, if it's getting steeper, it's also getting narrower for a given x value, isn't it? So it should be considered a horizontal shrink. Okay. It's getting narrower but steeper. But mainly we're going to think with this notation, we're going to think that it's a vertical stretch. Now, they will tell you in problems, how do these two graphs change with respect to the y-axis or with respect to the x-axis. If they talk about with respect to the x-axis, they're talking about stretching or shrinking this way, horizontally. Okay. With the y-axis, they're talking about up and down. Does it get stretched or does it get not? Huh? Yeah. Okay, so now we look at another kind of equations. We've talked about these already, I believe, haven't we? This kind, that, and that give you the vertex. Now remember that. Opposite of sine this, and that, they give you the vertex. Now, here is a rule. If you got an equation, simply that term in this format, this is called vertex form, then that opposite of sine and that same sign tell you the location of the vertex or the turning point on a quadrilateral. Okay. As k gets bigger, the vertex starts higher. As h gets bigger, the vertex moves either farther left or right, depending on the sign. Okay. If k is a negative, then the vertex starts getting lower, and so on. Now, the axis of symmetry. You notice these things are symmetric. Now, as long as we have the vertex right here, the y-axis was the line of symmetry in those examples I did earlier. But in this case, we have shifted the vertex over to here. Same shape, only shape shifted, to use some movie lingo. And but there is a line of symmetry. Well, guess what that line of symmetry is? It's that opposite of sine x value. Okay. And this is just telling you if A is positive, it opens upward. And get this, because there's a test question, kind of like this one. Now, in this particular example, A had to be a positive number because this thing's going up. The cup holds water. Right? Now, because of that, this is the lowest point on the graph, right? What do we call the lowest point on a loop? The minimum. So that vertex is a minimum. What if this were like this? What would the vertex be? A max. Okay. There is a test question coming. Okay. If you look at that list of things where it talks about max and min, you might know which problem I'm talking about. Okay, well, here's an example of the max. Okay, now we got a whole bunch of changes here. Whole bunch of them. Now here's the key. You work from the inside out. You work from the inside out. Now, what do the directions say? Just find the vertex is all it says on this one so far. Okay. Well, the point 3, 4. There's the vertex. That's how easy it is from this format. Now, they want you to sketch this. So, here's my graph paper. I've got the point 3, 4. Over 3, up 4. Right there it is. That is a positive. This is an x squared. So I've got a graph that's going to look like this. So this thing's going to go kind of up like that, kind of up like that. Well, there's something else that we can figure out that'll help us. By the way, if you recall, this number opposite of sine, this x, is also the line of symmetry. That means this thing's got to open equally this way and that way, spacing. Okay? Now, I need another point to graph this. And I'm not wanting to do an XY table. I can always do an XY table. But I don't want to do that. I'm lazy. I'm efficient. Okay? Might help to know where this thing crosses the y-axis. That is not the y-intercept on this form. But here's how you get the y-intercept. Replace that with 0. So -3 squared is 9 times 2, 18, plus 4, 22. I better carry this up here a little farther. So that gives me the point 0, 22. So that means this thing goes from here. Oh, I graphed this wrong. This goes over here on the y-axis, not on my symmetry line. So that means this thing has to curve like that. Pretty steep, right? Well, this side's got to go the same amount of steep because it's got to be the same distance from here to here as it is here to here. It's got to be the same distance here to here as it is here to here. Okay? Yes. The y-intercept. This is true anytime you want to find the y-intercept. Any and every time, no matter what kind of equation it is. Okay? Simply replace x with 0 because on the y-intercept, x is 0. So I replace this x with 0. That means that I've got 2 times -3 squared plus 4. That gives me 2 times 9 plus 4, which gives me 18 plus 4, which gives me 22. Okay, so the y-intercept then is 0, 22. Because intercepts are always points. Did that answer your question?
Yeah, I feel like that. I went over a little bit too fast.
Okay. Well, anytime you find the y-intercept, no matter what kind of an equation it is, all you do is replace with x with 0 and then do order of operations. So we graphed the thing without doing a data plot. Anytime you can avoid doing an XY data plot table, you're ahead. Well, there it is. They cheated on me and didn't go up to 22. But as you see, same distance apart, same distance apart, same distance apart, same distance apart. from here to there and from here to there, because that is the line of symmetry.
So how big is 3, 4?
Say what? Okay, this is what I went over before, the vertex. This opposite of sine and that. This is the x value opposite of sine, 3. And then there's the y value, up 4. Louder. If k is 0, then if it were 3, 0, if this were 0, that was still -3, then it would be right at here. Because x would be 3, y would be, if that were 0 or not there, then it would be here. Okay. Any other questions before I go on? Symmetry, axis of symmetry. Again, that comes from this opposite of sine. That gives you the axis of symmetry. X equals 3 in this case. It's just a simple statement of what is the x value. Okay. What is the minimum or max? Well, it is a minimum because it's a low point at 3, 4. Okay. Or the minimum is 4 when x is 3. Find the domain and range. What's the farthest to the left value that we could plug into this and get a valid answer? -infinity. I mean, we could do them right up to -infinity, which we would never reach. Same thing this way. Okay, so in this case, Buzz Lightyear. Okay, infinity to infinity. Now, what about the range? Range always, domain always goes left to right, like we read a book. But range always goes bottom to top. So what's the lowest point on this? Y equals 4. What's the highest point? Infinity. So the range then, here's the domain. The range is values bigger than 4. So, but we include the 4. So this would be what we would say the range is. Now you can just put R equals and D equals if I ask you what's the domain and what's the range. Make them capital R and capital D. Okay? You understand how domain and range work from the graph?
Why is the 4 behind the bracket?
What does bracket mean compared to parentheses? Inclusiveness.
Okay.
Is it included or is it not included? And that one, in that case, it's included. Okay, what about this equation? What's going to happen on this thing? Well, if we just got to identify the vertex, the answer is point -2, -7/4. Or for the sake of graphing, -1 3/4. Okay? You look confused. So,
Otherwise, I find 3/4.
yeah, okay. Divided 4 into 7 goes 1 time and 3 leftovers. Okay, so here is my vertex. That answers that question. Now, they're probably going to ask us some more stuff. Yes. Does this mean anything? The only thing they're really illustrating here is the opposite of sign business. That's where this negative came from, okay? And how that one is still same sign. And then this one is negative. What's this negative gonna do to my graph? It's gonna make it upside down, okay? So there's the vertex. And we're gonna still deal with the same equation. And we get rid of this. What's the line of symmetry, by the way? X equals -2, right? So here's my line of symmetry. Here's my vertex. I know it's got to go down. So that's a maximum. But how wide does it go down? Well, the easiest way to find out is get the y-intercept. Change this to 0. So that kills that off. So I've got 2 squared is 4, -4, minus 7/4. Well, -4 minus 7/4. I can't just add those like they are. So I've got to change this into -16/4 minus 7/4. In other words, the common denominator game. Okay. Multiply this by 4/4. So now I can combine those and I get -23/4, which for graphing's sake, 4 goes into 23 almost 6 times, 5 times with 3 leftovers. Right there, just above the 6 line. Okay. So if this goes here, a distance of left, right, 2, then from the same vertical distance, left, right, 2, we put a point there because of symmetry. So with this point, with those 2 points, I can pretty much draw this graph. Okay. And again, this is my max with a y value of -7/4. We've already done that. What is it? -2. Okay. What is the max or minimum? Well, that's a max at -7/4. Okay. Domain and range. Every parabola in the world is going to be infinity to infinity on the domain. Unless there's a less than or equal or a greater than involved instead of just a pure equals. What about the range on this time? The high point is -7/4. The low point is -infinity. But the range we always say from low to high. So here is the range. Standard form. That's what you're used to dealing with. That's what we did factoring forever on, wasn't it? Did you know that you can find the vertex out of this thing and do the same things that we just did on the other? And actually, some of it's a little easier, although the vertex itself is not easier. Well, let's look at this style of equation. Uh-oh, I got an upside down one. Okay. I do have a y-intercept of -16. That's a given point. So I don't have to calculate the y-intercept on, well, technically I could replace that x with a 0 and that x with a 0 and wipe out both of those terms, just leaving this one. Okay, so why bother? So if we want to graph this, the vertex on this is, they say 3, 2, but they don't give you any clue how. There's a formula that takes 2 steps. There's always a formula. There's a formula that takes 2 steps, and that's hard to hold this finger up vertical. Didn't want to do it. Okay? Oh, well, I'm holding these anyway. That formula to find the line of symmetry is x equals -b/2a. Now, I have talked to you about this before when I told you I just done common denominatoralizes. And that front end part is the symmetry formula. Guess what this thing, quadratic formula, really does? It gives you the line of symmetry, which also gives you the x value of the vertex at the same time. And this tells you the spacing on the x-axis away from that line of symmetry is what that does. Okay? It tells you how far over that way and how far over this way from that line of symmetry it is. So that's what the quadratic formula really does for you. Now, that formula right there applied to this problem. B is 12. -12 over 2 times A, which is -2, equals positive, negative times negative, 12 divided by 2, or by 4, I mean, is 4. No, it's positive 4, because this negative and that negative cancel each other out. I skipped a step.
Sorry.
-12 over -4 equals 3.
Sorry.
That's okay. No need to be sorry. So that's where this came from. Then I'm going to take this 3 and sub it in to get the y value. -2 times 3 squared plus 12 times 3 minus 16. Okay, -2 times 9 plus 3 times 12 is 36 minus 16. This gives me -18. I don't know what those dots are doing there, left over from something. Plus 36 minus 16. Well, -18 and 36 give you positive 18. Because 2 times 18 is 36. Minus 16 gives me an answer of 2. Okay?
Okay.
This, from there, gives me that. Substitute that value in to get this. Okay? So if we get ready to graph this thing, my line of symmetry is 3. My vertex is 3, 2. Somewhere like right there. My y-intercept is negative 16. I have a negative, so this thing has to open down. It has to go this way. And likewise this way, same distance here, whoops. Same distance here, same distance there. Same distance here, same distance here. I didn't draw this thing very accurately, did I? Well, let's redraw this so it's more symmetry. Like so. Did I make the point of the symmetry then? What? What? I didn't understand.
I saw the x-intercept on 2.
Oh, well, we're not to the x-intercepts yet. We haven't done that yet. Now, they're going to be here and here. Okay? Right here and right here are going to be the x-intercepts. But let's see what we've done up to this point. We found the vertex. We got the axis of symmetry, or line of symmetry. We know that the max is 2 right here, okay? The y-intercept is this point 0, negative 16. We knew that from this. The only other thing we need to find are what are the x-intercepts, which we also call the zeros or the roots. Okay? Now, if I were doing that problem, I wouldn't even try to factor. You could, maybe, I don't know. It's been a while since I worked this problem. Okay, I've slept since then. But I can throw it in the quadratic formula and get it for sure. So that's what I'm going to do. I just conveniently happen to have my formula written over here. So I can substitute in equals negative, well, b is 12 plus or minus square root of 12 squared minus 4 times a, which is negative 2, times c, which is negative 16, all over 2 times a, which is negative 2. Okay? Equals negative 12 plus or minus square root of 144 minus times minus is positive times minus is negative minus 4 times 2 is 8 times 2. Uh-oh, I don't like that. 4 times 16 is 64 times 2 is 128. I mean, they're the same numbers, but some ways it just works in your head easier than others. And when it's all multiplication, the order doesn't matter. So 128 goes here, all over negative 4. Okay? Equals negative 12 plus or minus square root of 144 minus 128. Somebody help me out. How much? 16. Oh, how nice. Over negative 4. With a perfect square there, I'm going to get 2 real numbers. Okay. Well, this gives me negative 12 plus or minus 4 over negative 4. Now, that breaks it into 2 problems, my positive and my negative. Okay, so negative 12 plus 4 over negative 4 equals -8 over -4 equals, and I'm probably getting off the side of my video right now,
Positive 2.
so equals +2. This one, -12 minus 4 over -4 equals -16 over -4 equals +4. Okay? Now, what these mean is I've got the values. This gives me this value right here is the point 0, 2, and this is the point 0.
2, 0, 4, 0.
4, 0.
Yes. What?
2, 0, and 4, 0. That's it.
Yeah. 2, 0, and 4, 0. Those 2 points. Now, I told you earlier that this thing could show you the line of symmetry and the spread. Let me go back up to this step. Let me go back up to this step. Take this part right here. I'm going to take it over here where I got room to work. -12 plus or minus square root of 16 over -4. I can uncommon denominatorialize this thing, and I get -12 over -4 plus or minus square root of 16 over -4, right? This gives me +3. Ding! Plus or minus, in this case, 4 over -4, okay? So what this is saying, this piece is gonna give me +3 for my line, and plus or minus a 1. From the line of symmetry, +1 this way, -1 this way. From the line of symmetry. That's what I was talking about earlier on that. Okay? How the quadratic formula is broken down.
So when you're saying that the other half of the equation with the square root of b squared minus 4ac over 2a.
Yeah,
What
that
you're
tells
saying
you the distance
between the line of symmetry and the
x value on the x-axis.
Okay, all right. That's where I was questioning.
Now, if it's an imaginary,
Right.
you can't graph it.
Right. Well, if it's imaginary, it's not going to have x-intercepts. So.
Right. It'll be something like this or something like that. Okay. Can I go on? I suppose they're gonna show me all the work on this one now that I've done it.
Probably.
Well, that looks kind of familiar, except a little prettier. But you notice the X and Y values, exactly what we got. Here, 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 and here. Okay. Vertex formula. Well, believe it or not, we've already covered that sucker. What do we do? -b over 2a to get the x value. And this notation means we're going to substitute it in to get the y value. That's all this notation. If you ever see that, just know that you got to substitute the x into the equation to get the y. And then forget you ever saw that. Okay, that hurts. Okay, Vertex and intercepts of a quadratic function. This is more of the same. Okay. Here they're just substituting this 1 into that to get the y. I mean, how many times have we done that already tonight? Okay, here we go again. Find the x and y intercepts. If you can factor it, that's the fastest way. If you can factor it. If you can't, quadratic is your fallback. It works on all of them. Okay. Y-intercepts, well, that's easy. If it's in standard form, it's just this. What if it's in vertex form? Then you got to replace x with 0 and work it out. Okay. So we get that. This one is prime. So we gotta use the quadratic formula. Prime means it won't factor. Okay. So we put it in there, we work it out. Uh-oh, we're gonna get an imaginary area. Okay. What does that also mean? That means it ain't gonna go ever cross the x-axis. So there won't be x-intercepts. Although there will be imaginary values you can get, which is that. This is still the line of symmetry. But that is unmeasurable. What do you do on this one to get the actual shape of the graph? Pick some x and y points, or pick some x values and plug in y's. Some x values on each side of this. In this case, because that's the line of symmetry. Yeah. Remember what I just showed you over here? Okay, here's this problem.
So if you get imaginary, it can still cross the y-axis?
Yes.
Yes, absolutely. Here's the 5 right there. Okay. 1 was the line of symmetry. All that 2i down on that answer before, men, is presumably this is some factor of 2i to go across there, but usually they mean on the x-axis, but this never touches the x-axis. So anytime you have imaginary, then the graph is completely above or completely below. Okay, now we're going to skip over that because that's too scrabbly. You got this handout in front of you. This is homework. Now, let's look at this thing. Now, I'm doing 2 different things with this problem, okay? This is the same problem in vertex form and in standard form. It's the same problem. You remember I told you earlier we were going to skip how to convert standard form into vertex form by a process called completing the square. Well, I invented a method to convert it without using the completing the square, and is a whole lot easier. And that's what the top half of this sheet is showing. Okay. I'm starting with this equation, 3x squared minus 6x minus 1. Ultimately, we will find out that it becomes this. Now, one thing you need to notice right away, 3 in front of the x squared, 3 in front of the x squared. The a stays the same, which I have written right here, a equals 3. Now, we can find the vertex out of either format. If we know this format to start with, the vertex is going to be +1, -4. If we don't know the vertex in this format, -b/2a, and we get 1 for the x value. We substitute the 1 into the equation, and we get the -4. So either way, we've still got the same vertex. Okay? So here is my A term, here is my vertex. If I know the vertex and I know the A term, I can write this equation. The x value of the vertex opposite of sign, and the y value same sign, with the A term in front. Now, that's a fairly easy way to do it. Just find the vertex and put them into that format. This is what they call completing the square. I put it up here just for you to see, not for you to know. Okay? It has its own formula, b/2 squared, as a missing term to supply. You take the -1 on the other side. In this case, because you've got an A there of 3, you have to divide every term by 3. That's where this third came from. 3 out of 3 gives you 1. 3 out of 6 gives you 2. 1 out of 3 gives you 1/3. Then I have to do this thing. -2/2 squared gives me a 1 in this case. So that gives me this equation. That equation is a perfect square that will factor into this. And that'll always work that way. Over here, I got to use common denominator things before I can add the 1. If I add 1 on one side, I got to add 1 on the other side. So I changed a 1 to 3/3 so I could combine those and get 4/3. Now what I did is I divided both sides by 3. These two 3's cancel, that one's there. Or I didn't divide both sides, I multiplied both sides. And I got that format of equation. Whole lot more work. I think you see that my method is much easier, I hope.
Yeah, that completing the square.
Completing the square is horrible. I agree with you fully. I despise it. It does have its use some in circles, but fortunately in this course, we don't have to deal with that. Actually, you don't in 111 either. You used to, but not anymore. So anyway, what are the steps to change from one to the other if you have to? And by the way, you're going to need to for sure on one problem on your test, exam 4. So you better pay attention to this side. What did I do? I used the vertex formula, -b/2a, to get the x value, substituted in to get the y value of the vertex. So I've got the vertex, I've got the a term, and I just write the equation. Okay. Now, here's your homework. I've already found the vertex for you in this problem. And consequently, I've also found the line of symmetry for you. Okay. But what you need to do is find the x-intercepts. You need to graph all of this information right here. Now, you're going to have to use the quadratic formula to get the x-intercepts. And you're going to get, when your answer from the quadratic formula, you're going to end up with a square root of 3 in. So that's why I'm telling you that the value of the square root of 3 is approximately 1.732. So you can figure out where to graph the point with your plus and your minus side of the quadratic equation, which you've seen me do before. That's fundamentally what the question is. This is just a hint, and those are things that'll help you get it. Okay. Bring this back with you on tomorrow night. Okay.
Mhm.
Well, let's keep going. Wish I could let you go right now. Inequalities. Okay. You guys have seen this before. I mean, these are the four kinds of inequalities. With or without the equals, the inclusiveness, the junkyard dog fence. Okay, here's a question. Here's an equation. Here's the basic equation if it had an equal, but they modified it to put this less than 0. Now, in Alex, they might try to teach you a thing about using test points. Plot the x-intercepts, the roots, the zeros, and then try points on each side of them to see whether they come out positive or negative. Because what this symbol is really telling you is they want to know what part of this shape is, in this case, below the x-axis. That's what that means right there. What part of this shape is below the x-axis, and we don't include anything on the x-axis itself. If there were an equal there, then we would include the point on the x-axis. And your answer is ultimately going to be interval notation. Okay? Now, in this case, if we graph this, we get this shape. Okay? Here's my line of symmetry. Here are my two x values. Now they've got circles there instead of points because this does not include those on the y = 0 value. Okay? That's correct. That's correct. So these 2 points are not actually included, or anything that's on that line, the x-axis. So what is the answer to this question? Well, it's anything where the graph is below that x-axis. Okay, well, what is that? Well, it is, in this case, anything below, right? We can't include the 1. That's not a bracket, that's a parentheses. And from there to the 5. And we can't include it. So what they're saying is any x value between these two, but not including these two themselves, will give you a point on this graph that is less than 0. That's what that's saying. Okay.
So does it still have to be equal parabola as well?
The graph is the line. It's anything that falls on this line that is within that region.
Okay.
It's actually the line though. Okay. So if x is 2, it's this point right here. Yeah, that would be part of the answer. If x is 3, it would be this point right here. That's below 0. So that would be part of the answer. If x is 4, it would be right here. That's part of the answer. And so on. Okay? This is basically saying what X values are below the line, is what this question is asking, to word it another way. This problem, on the other hand, same graph, except this time we say above the line. So if we're talking above the line, then, but not including the line, again, we're leaving out the points on the line, but it's anything that's this way from there.
So this kind of like what we're doing.
Because this is gonna go forever.
This is kind of like when we had to do the, when we asked like the area of points on the line where we had to either shade like above or below it or whatever.
Yes.
When you did these and when you did this. This answer right here is one of these. Because you're asking, what are the set of X values that meet this rule? This shape and above the line. Well, right here is 1, here is 5. And it's everything this way and everything that way, because this thing keeps going that way. And that thing keeps going that way. So what is my answer then? Negative infinity to 1. Union with 5 to positive infinity. I've got a gap from here to here that's not above the line. When you put a union symbol, that always means I got a gap. Not you went shopping at the store. Okay? So you kind of hopefully start to understand what this is doing? Yes.
So how come it's not anything above the line, but inside of the bracket? Like,
It's everything, not including this point itself, but everything that would go that direction. Because this thing keeps going this way. Up and out, up and out, up and out.
so it's only, so if it's greater than 0, then it's everything on the outside of the bracket.
No, 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 no. If it's greater than 0, it's what part of the graph is above the line. All of this is above the line. All of that is above the x-axis.
So the other green.
No, this part in between it's below. This part down here is below the x-axis.
Right, I'm talking about.
The part above is anything from here out that direction, or anything from here out that direction. I didn't hear you. Uh-huh. You're looking for what's above the line or what's below the line, depending on the symbol. Okay? If they've got an or equal, then we would have to change these to brackets if they had or equal. Okay? Because then the point would be included that is on the line. Okay?
So if there were brackets, it would be every single value of.
No. Only difference is we would include the 0.1 and the 0.5.
I think he was asking, like, you know, how does that way, and what about the space in between?
You're asking about what here?
Yeah.
Well, right there is the value that's in there, right here. You know, I mean, this point right here was covered by right there. What? This point right here was covered by that point in terms of what is on the x-axis.
So what she just asked was what I was
I don't know.
Okay. It's, the question is, what X values would be true if you put it in there? Okay, you're determining what X values would be true if we substituted them in. For example, right here, if we have X equals 1, and we put a 1 in every X value here, 1 squared minus 6 times 1 plus 5 less than 0. 1 minus 6 plus 5 less than 0. 1 minus 6 is 5 plus 5 is 10. Okay, negative 6 rather. 1 minus 6, that's negative 5 plus 5 equals 0. But 0 is not less than 0. So that's why 1 is not included. If this were or equals, then that would be a true statement. And that's the difference and why we have the parentheses or the brackets. Well, guess what, people? We are 100% caught up. You have a test on the 10th, Thursday of this week. Okay.
Don't get that tomorrow.
What?
I early voted.
So did I. Vote tomorrow if you haven't.
On small